producer, and I've been on the TIEEP board for, I guess, about 6 or 7 months. Excited for all of you to join us in person and also on Zoom. Are we good on Zoom, Alan? All right, so just a couple of housekeeping things. So first of all, safety. So we don't anticipate there's going to be any kind of safety event, fire alarm or anything like that. But just be aware there are 3 exits, 1 at the rear and 2 at the front, 1 on each side in case you need to exit the building because there's something going on here with dinner or otherwise. Also, if you have not yet checked in at the back table with the guy who's raising his hand and shaking, he's got a mint there as a prize if you check in. But make sure you do that during one of our transitions. So we're going to be doing 3 presentations tonight. We'll have a couple minutes, 1 or 2 between each one. So if you haven't yet signed into the meeting, please go ahead and do that. All right, without any further ado, I'll go ahead and get us kicked off tonight. So as we said, on behalf of the Texas Industrial Energy Efficiency Program, welcome to today's Energy Forum on basically energy efficiency and decarbonization of process industries. So we're going to have 3 presentations tonight. Those presentations are around the DOE program on energy intensive manufacturers and a lot of support that DOE has got set up to really help deploy capital and resources to help you decarbonize your production. Second, we're going to talk with Schneider Electric on decarbonizing your process and your industry through electrification and digitization. So a really interesting topic there. And then last but not least, we're going to go through a presentation by Siemens on really how hydrogen can be a tool to decarbonize your existing gas turbines. So, and all of this has a central theme around decarbonization. So it's become an imperative as we think about our footprint as an industry, how we can minimize our scope 1 emissions and how that kind of impacts our communities and obviously the products that we sell downstream. And energy efficiency is kind of a logical first step there. And because energy efficiency often reduces your power bill, which delivers its own set of benefits and savings. And so when you layer on top of that the economic benefits, on top of the economic benefits, the environmental, you really see there's a lot of motivation to make these changes. So these 3 presentations are really going to be key to help educate this group. All right, so we'll talk a little bit more on those slides in a second, but I want to make a couple points. So thank you very much to our sponsors, our gold sponsors, SPX and Marley. And without those sponsors, you know, this whole thing would be very difficult to do. And so could the SPX contingent please stand up for us? Oh, there he is in the back. Okay. And so thank you very much. We're also going to acknowledge AICHE's silver sponsors, which is Schneider Electric and Ingeniero. Could their reps please stand up? So we got Schneider here, Ingeniero. Perfect. Thank you. So we should be finished right around 6 p.m. and the AICHE meeting starts at 6:45, the dinner, and then the team's meeting at 7:15. So please take some time to interact with our sponsors during it and thank them for our support for these TIEEP events. All right, so next we have, for folks who are interested, we'll have some PDH certificates available at the end of the forum. So we'll have a URL code, a URL, and a QR code that you can scan to get those. And again, these PDH certificates can be used for continuing education in the state of Texas and many other states. But just, you know, understand that it does vary from state to state. So make sure you check your regulations there. All right, so we will have 4 presentations. Each presentation will take about 30 minutes. We'll have about 20 minutes for the presentations and about 2 minutes for Q&A. So if you're in the room, jot your questions down. We'll make sure that we capture as many of those as we can during the Q&A section. And if you're on the Zoom meeting, please go ahead and put those into the chat. Alan will aggregate those and we'll try to make sure that we're doing a good balance at the end of doing the in-person and the Q&A from Teams, or Zoom, excuse me. All right, so our first presentation is going to be from the Department of Energy on technical assistance for energy intensive manufacturing. So they're launching a 2-year program to basically support energy intensive manufacturers through improving energy performance, decarbonization, and competitiveness of their facilities. So this is a pretty exciting program where the DOE will basically help you figure out ways to make your plants better. So our 2 speakers today, who I'll be introducing and then handing over the mic to them. First of all is Zach Pritchard. He's a fellow within the Department of Energy's Industrial Efficiency and Decarbonization Office. and he supports activities related to cross-sector technology, R&D, strategic analysis, and technical assistance. He's a chemical engineer with a deep background in technology applications with time spent in public policy, really helping to lead efforts at the state level around renewable energy policies, including standardization of portfolios. Prior to working for the DOE, he was also a ASME Congressional Science and Engineering Fellow in the House of Representatives, supporting the House of Representatives. The next also is Senthil Kumar. He's the technical account manager for the US's DOE Better Plants program. Better Plants program has been around for quite a few years, and it's a really powerful program if you haven't yet investigated it, to see how you can leverage their understanding and learnings to improve your own operations. He's an associate R&D staff member and technical account manager for the program at Oak Ridge National Laboratory, with research focused on industrial efficiency and decarbonization, both of which is an important topic for tonight. He's also a certified energy manager and qualified specialist in areas of process heating and steam. So let me turn it over to Zach and Saneeth. And again, thank you very much.
Great, thank you so much. So let's dive right into this. As mentioned, so the pilot that we're going to be talking about today, we are working on finding the best way that we can serve energy intensive companies. And a real key throughout this pilot is going to be getting feedback from folks, both participants and even if you choose not to participate, we want to hear what you have to say. So that's why we're here today. In addition, we're going to talk a little bit about what our office does more broadly beyond just this pilot program, so folks can be introduced, and we will get started on that. So starting with DOE overall, DOE is working now to catalyze economy-wide decarbonization, and that is with the deadline of 2050. So in doing that, we look across the entire innovation ecosystem as we think about it, the entire pipeline, starting from basic research and applied research, moving through demonstration scale projects, deployment efforts, and looking at technical assistance to adoption of existing technologies as well. And DOE and IETO have touch points all throughout that stream. As we look at doing this, of course, we're working to create good paying jobs. We're working to promote environmental and energy justice. And the key to making all this work is collaborating with our industrial partners, collaborating with researchers to figure out how to solve what is one of the greatest challenges that our country is facing. So folks may or may not be familiar with the Advanced Manufacturing Office. If you're familiar with Better Plants, then the Advanced Manufacturing Office is where Better Plants lived for a long time. As of October last year, though, the Advanced Manufacturing Office kind of took a hard look at the huge range of work we were doing and has evolved into now 2 offices. So I'm here from the Industrial Efficiency and Decarbonization Office, which is focused on, well, maybe we'll say that for the next slide, which gets into that in a little more detail. Our sister office now that split out of the Advanced Manufacturing Office is the Advanced Materials and Manufacturing Technologies Office, which looks at some of those fundamental advancements in manufacturing to promote competitiveness of US manufacturers. So on the IETO side, we're looking to increase energy efficiency in manufacturing, to drive energy productivity, to drive economic growth, and to promote decarbonization. Manufacturing is, of course, a major energy user, a major source of emissions in the United States and globally. And so we invest in research and development efforts for technologies that will address those emissions and that energy use. And I want to, maybe in particular point to some of the things on the right here, some goals that are relevant to this pilot program we're working on, that we're looking at reducing life cycle energy and resource impacts of manufactured goods. We're looking at how to provide training and to strengthen the US manufacturing workforce. And we're working to accelerate the deployment of emerging transformative technologies that will reduce greenhouse gas emissions. Within the program, there are several subprograms, several pillars. So I'm going to talk or touch a little bit later on the R&D efforts that our office works on. But this pilot program we're here to talk about today lives under technical partnerships part of the office. So technical partnerships works with partners in industry to help promote adoption of energy efficiency technologies and technologies that reduce greenhouse gas emissions. And the main maybe kind of banner program that you might be familiar with is the Better Plants program. The Industrial Investment Centers program, which is a little hard to see, it's grayed out intentionally, but that lived within the Advanced Manufacturing Office for a long time. We still have strong connections there, but that has moved to a different part of the DOE organizational structure, but always happy to help connect folks there. It works primarily with small and medium-sized manufacturers. We also have 50,001 Ready program, which it helps promote the 50,001 standard, and then CHP technical assistance partnerships. And the tech assistance program really works on producing a lot of different tools and software as well that are provided to manufacturers free of charge to help them reduce their energy use and to adopt best practices. Over the course of all of these programs, though, something we found is that the program has had trouble engaging with energy intensive industries. These are the part of the manufacturing sector that is using the most energy, that is producing the most emissions, but we've had trouble engaging with them in some of our existing programs, such as Better Plants. And going forward, we are really interested in understanding the challenges that are being faced by energy intensive industries and helping them to address those challenges. So that is what this pilot is all about. We want to understand the technical assistance needs for energy intensive sectors and to find the right structure of a program that could meet those needs. Starting out, what we've been looking at is working with a cohort of energy intensive manufacturers to help to work through ideas for what kind of support would be valuable. We have some initial ideas. We're also open to new ideas, just trying to create this feedback loop to understand how we can be most helpful. And so what I'm going to do now is I'm going to hand it over to Senthil, and he's going to go through what kinds of programmatic offerings we have available now to see if that catches anyone's eye. Senthil.
Thank you, Zach. I don't think I need a mic, but I'm pretty loud, but bear with me here. So as Zach mentioned, this program, this pilot initiative is all about you guys, right? We want to get your honest feedback, honest opinion on what you think about these technical assistants. It's not just about giving you guys a questionnaire and then getting your feedback, although we do have questionnaires, by the way. We want you to fill out and give your honest opinion, but it just not stops with that, right? We also want you to take advantage of our technical assistance activities through which we want your honest feedback. So our technical assistance activities includes energy and decarbonization assessments. We try to put this into 3 buckets, right? The energy and decarbonization assessments, comprehensive in-plant trainings on energy systems, and technology demonstration activities. And I'm going to expand on these more in the coming slides. But bottom line is we want to get to understand the ground reality of, what are some of the operational challenges that as energy intensives you guys are facing from an energy efficiency and decarbonization perspective. There is no commitment or there is no goal for this. It's completely voluntary. You receive, and we are not vendors trying to sell you anything. It is, we provide you with unbiased technical assistance. So think in terms of this is like more of a mutual agreement where we are trying to learn from each other. So as Zach mentioned, we have a flagship program that has been successful for the past 12, 13 years, which we call as the Better Plans program, right? But the Better Plans program, we have close to 270 plus manufacturing partners who work with us through the program. But for some reason or the other, we were not able to attract the energy intensives on the program. And we do, although we do have quite a few amount of energy intensives in the program, we do not have the whole spectrum there, right? And the reasons could be several, and that is what we want to understand. It could be because Better Plans program requires a commitment, and there is a goal, which is 25% reduction in energy intensity over a certain period of time. Maybe that is too ambitious for you guys. So that is what we are trying to understand. What would be the realistic goal? How much of energy intensity can you guys really reduce, or what is the carbon reduction that you can achieve over the years, right? That's what we want to understand. We want you guys to take advantage of all the technical assistance activities, try it out. Let us know what works, what doesn't work, what makes sense. And which one of these resources are more impactful for your cases, right? And I have to tell you, we might not have the solution, all the solutions that you guys are looking for through these programs, right? And that is fine. And that is what we are trying to get from this initiative or this pilot period, right? We want to understand what more resources we can develop that are specifically focused for energy intensive industries. And you might ask, like, what are you guys going to do with all the information feedback that you guys are collecting from this? We are going to move this up the chain, and we are going to advise DOE of, hey, these are the feedbacks that we got from some of these energy intensive industries that we are working with. And this is what a program, we are going to come up with a permanent program after 2 years pilot period, which which will address most of the learnings that we get through this pilot initiative. So you can request technical assistance through our website, which Zach will be sharing in the end. But depending on the type of technical assistance you guys ask for, we'll be deploying the subject matter experts your facilities. And these SMEs, the subject matter experts, have 30 plus years of experience in their particular field. So they can do industrial system assessments, compressed air assessments, process heating, steam system, and process cooling system assessments. And they can also do decarbonization assessments, focusing on alternative technologies and energy resources. And they can also work with you for any process improvement or productivity enhancement assessments. And lastly, the CHP, we have a technical assistance partnership with the CHP TAPS. And right now, actually, they are expanding to have a much more capability than just CHP, where they are now, they are calling themselves as on-site generation assistants, which includes fuel cells, on-site storage, and stuff like that. So they can help you in doing a feasibility study if CHP works or any on-site generation technology works for your facilities, and they can also provide you with engineering support as well. And our subject matter experts are equipped with not only doing energy assessment, but also non-energy assessments, focusing on water efficiency improvement and waste reduction activities. And not only that, they are also equipped to do a plant-wide assessment. Say if you do not want to just focus on one particular system, but you want to look at all the systems. So as Zach mentioned, we have a partnership with industrial assessment centers who can do a plant-wide assessments. Who can look at multiple systems in your facilities and can come up with opportunities, right? They do have limitations. The ISCs are equipped to do audits only for small and medium-sized facilities. So in your case, if you guys have any small and medium-sized facilities, you guys can take advantage of these assessments. And these ISC centers are located out of universities, which are strategically located across the US. And nice thing about this is this year, they have the capability to provide implementation grant. They have access to implementation grant. So let's say if they come into your facility and do an energy audit, and they give you a bunch of recommendations, right? And if you implement those recommendations, to implement those projects, you can take advantage of the grants that are available through the program. Over the years, we have developed a bunch of tools, like so many tools. And if I start talking about all of them, you'll be bored to death. But some of the important tools here is, obviously we have the energy system optimization tool, which we call as Measure, manufacturing energy assessment survey tool, which is one-stop shop for energy system optimization, right? It has inbuilt modules, compressed air module, motor systems, fans, process heating, steam, you name it, we have everything there. And it has more than 60 plus calculators to do a what-if analysis. and quantify your energy and carbon reductions. And we have a utility dashboard platform where it takes your utility bills and comes up with opportunities for cost reduction and water efficiency tools. And decarbonization these days taking a front seat, we are now developing a lot of decarbonization tools as well, which can quantify your scope 1 and 2 emissions, and which will also help you to develop a roadmap for the future years to come. And again, like I said, we have a lot more tools that are available, and Zach will be flashing a QR code in the end, which will take you through the website, and you can look at all the other tools that we have through the program. From a workforce development perspective, as participants in this pilot initiative, you will have a chance to, you will have an opportunity to host these in-plant trainings. So these in-plant trainings are a nice way to train your workforce, because we deploy a subject matter expert to your facility who spends 2-3 days in your facility training your plant personnel. You can invite multiple personnel from different facilities to one particular facility and have a subject matter expert come in, walk them through an assessment, show how to do an assessment, use the diagnostic equipments, and how to quantify, how to use some of these software tools that we are talking about, and how to quantify energy and carbon reduction opportunities. So some of the in-plant training topics that we have done over the years, this is on energy systems, compressed air, motors, process heating, steam, industrial refrigeration, water efficiency, and strategic energy management. The other workforce development activity that we have is a trash run. We can facilitate the trash runs. The only difference here is obviously the facility personnel will be doing most of the heavy lifting, right? We are there to just facilitate. So they are going to have a cross-functional team who will be brainstorming ideas. The facility personnel will split into groups. They go and look into opportunities, and then we will help them to, basically how to use the instruments and, how to quantify some of these opportunities that they have identified during the walkthroughs and stuff like that. And last piece is DOE has almost 17 national labs across the US. So every year we host a technology day at each one of these labs. So you get an opportunity to tour the state-of-the-art facilities, these labs, and also you get a first-hand demonstration of some of these new and emerging technologies from industry experts and vendors who showcase their products. It can be carbon capture, or it can be electrification, and so on and so forth. And obviously the last piece is, supporting more of R&D efforts, collaborating with DOE for more research development and demonstration. So Zach will be talking more on that. But what I would recommend is, for those of you here, please stop by our nice station in the corner. And, we have our brochures, we have our fact sheets, we have the questionnaires. Please spend some time. It's a 2-pager, and it's just checking a box, right? And I would highly recommend you guys to do that. If not, then I think I'll buy. Beer is on me. But for those of you who are online, again, Zach will be flashing a QR code in the end. Once you guys scan that, it'll take you to the form, SurveyMonkey form, and you guys can fill the questionnaire through that form. I think I'll hand it over to Zach. Thank you.
Yeah. So before we wrap that up, I'm just going to very quickly touch on some of the R&D work that's happening at DOE and in IEDO specifically, because that's a huge thrust of what our office does and might be of interest to folks. So DOE's strategy on energy efficiency and decarbonization of industry is outlined by this industrial decarbonization roadmap that was published last year. We think about our approach to decarbonization through several different pillars. The use of carbon capture, utilization, and storage, the use of electrification technologies, the adoption of low carbon fuels, feedstocks, and energy sources, energy efficiency measures, and then also some fundamental manufacturing technology innovations. And if you're confused about where all of this happens in DOE, know that you're not alone. Those of us in DOE are often confused about what's going on in DOE. There's a huge landscape here. So this is kind of showing for those different pillars as technologies advance from kind of fundamental science to deployed out in the field, what different offices are working on that. And it is a complicated landscape. At IEDO, we work in this space of research and development and pilot scale demonstrations, kind of first of a kind demonstrations, and on the technical assistance end, and we work across all of those different pillars of decarbonization. I will just kind of to know, I think, if you're interested in funding for research and development from the Department of Energy, absolutely go to our website, subscribe to our newsletter. You'll be among the first to know about any funding opportunities that are released. We take a strategy in our office, both focused on specific subsectors and industries that are significant energy users, and also thinking about cross-sectoral approaches for equipment and other technologies that can apply in a number of industries. And so the big money news that's out there, this very first one, when you get a copy of the slides, you can click on those links, or you can go to our website to find out about them. We have the notice of intent that's linked there, but actually the full funding opportunity just got posted yesterday. So IEDO has $156 million available for decarbonization and energy efficiency research in the industrial sector, $23 million announcement out for technical assistance partnerships. And then in broader DOE, there's a very large funding opportunity available right now with the Office of Clean Energy Demonstrations. So this is looking a little farther along in technology development and demonstration projects out there. And this is again focused on the industrial sector. There's also tax credits that are available, which I told someone earlier, I'm not a tax lawyer. Don't ask me specific questions about your taxes, but DOE is working on this. Finally, just to wrap up here, so this QR code, I think, is fully on the screen. This will take you to the survey that we have available, asking about your needs. Our process here, we have our website. You can submit a request for technical assistance. We have a kind of informal 30-minute conversation about what your priorities are, what you would want out of this relationship. We, will arrange to send folks out to your facilities to provide whatever assistance we've done. And then, after, we would just ask to continue that conversation, to provide feedback. And we'll keep you in the loop as well on future opportunities that we have available. So finally, we can open up for questions here. This other QR code goes to our website for the pilot initiative. We also have this stuff available on our flyer if you're here in person. So we'll be hanging out by the poster for any questions we don't get to later. Happy to talk.
Perfect. Thank you. Any questions in the room for Zach or Sanith or Cynthia? Sorry. Yeah, I have a question. If you would, let's see, over here, Frank. Just name and your question, and we'll do one from Zoom next.
Testing one. Yeah, Bill Shaw. I worked at the DOE in Morgantown for a little bit. One of my questions was, does it cost for the assessments? And what do you consider small or medium size?
The short answer is no. So does it cost anything?
It is free. It is free. So, but as for small and yeah, we don't say that explicitly. But small and medium size is basically if the utility bill is less than $100 million. So anything less than $100 million, it is qualified as small and medium sized facilities.
Thank you.
Online? No questions online? Okay, another question for the room?
I've got one. Is that still? So the question, I'm familiar with some of the programs like the energy assessment centers, and I know that if you're above a certain size, you're totally excluded from those. But then you talked about wanting to get large companies in as well too. So how does that work out?
So the whole point here is, again, if it is a small size, medium size facilities, and if they want plant-wide assessments, we work with the IAC centers to go and do the assessment. But if it is a large facility and if they are looking at any specific decarbonization assessment or system specific assessment, we work with our subject matter experts who gets deployed to the facilities and do the assessments. So short answer is we can do both small, medium, and large facilities as well.
Thanks.
Okay, let me ask one here. So we looked at our company, we looked at the Better Plants Initiative about 2 years ago and kind of struggled with the level of improvement we would have to make and kind of the resources and stuff. So obviously the pilot is part of kind of trying to address that resistance to get in. Do you have any examples though from the previous Better Plants implementation or even the energy integration studies that maybe could highlight to the team here about, you know, some of the wins that you guys saw?
Sure. I think Better Plans program itself, we have close to, like I said, 270 partners in the Better Plans program. And whenever they sign up for Better Plans program, they sign up for a goal, which is 25% reduction in energy intensity over 10 years. So out of the 250, 270 partners, we have close to 75 players. So that is pretty significant. And they have worked with us over the years, like 10 years, where they have taken advantage of all the resources that I was talking about, in-plant trainings, technology demonstrations, and also, you know, energy assessments and so on and so forth. So that's the impact that we have made so far through the Better Plans program. And again, like I said, for some reason or the other, because energy intensive, the way they are, the nature of their, you know, the production and stuff with the manufacturing process itself, 25% might be significant. Reduction in energy intensity might be significant. So maybe that is one of the reasons probably we were not able to pull much of these energy intensives in the program. But that is why we really want to try this out and see. And after the 2-year pilot period, we will come up with a realistic goal that actually makes sense for energy intensives.
Good, thank you. Any other questions? We got about 4 or 5 minutes in here. All right.
Yeah, great presentation. Enjoyed the information. Most of us here work for companies that have stockholders that require that we all make a profit return to our investors. So to do all this stuff at some point in time, there's got to be a price on carbon. So what is your thoughts on that?
Yeah, I mean, one thing I would say is that I think this is something that certainly the SMEs will work with plants on is, you know, figuring out the opportunities, what is in the money and what isn't. I think, you know, one of the focuses on, well, I think the tech assistance group is thinking about this too. We're also thinking about integrating it throughout our R&D projects, is starting to think more broadly about how we account for the cost of technologies. I think, you know, when you look at some of the early stage, for example, electrified technologies, in those cases, you know, we know that electricity is more expensive than natural gas, right? If you're just looking at energy costs, if you're looking at some of the conventional accounting around these technologies, they don't pencil out. If you start to look at the bigger picture around maybe increased reliability, lower maintenance costs, these kinds of things, it, you know, starts to balance in different directions. And so I think one of the things that we try to think about is what is the bigger picture. And of course, we also are, you know, always looking to work with companies who are interested in looking, you know, in being the first adopters and in taking those steps. You know, the first implementations of technology is never the cheapest implementation of that technology, folks. This is why DOE is involved, is to try to help de-risk these technologies and get them to the point where they make sense from a business perspective to be adopted. I don't know, Senthil, if you have anything to add.
It's a great question. And one other thing too, you know, I've been in industry a little while, and I can remember a decade ago when natural gas was $7, $8, $9, $10 per minimum BTU. We had a whole list of projects that were energy efficiency projects. Those have been sitting on a shelf now for 10 years, and they're really making a comeback. So I think there is a return on investment for a lot of these type of implementations. It just has to, you know, how long will gas stay high or electricity stay high is kind of the question on the board. But hopefully this can de-risk and decouple maybe resources from those evaluations. So yeah,
So back when I worked for a refinery, one of the easiest way to cut the EII was just run more barrels.
Yep.
So are you guys really focused on reducing the overall energy consumption, or can you meet your goals by just putting out more widgets and running more barrels?
I think, again, energy efficiency is what we are focusing on primarily, right? It is a foundational step that it's a logical place to look after first. So all our subject matter experts, obviously, though they will be suggesting some capital investments, technology suggestions and stuff like that, but they are going to primarily look at overall energy consumption reduction. Primarily focusing on energy efficiency improvement like waste heat recovery or oxygen reduction in your furnace. So stuff like that. Most of the energy efficiency improvement is what they'll be targeting first. Did I answer that question?
Anything on Zoom? Oh, sure.
That was not a good idea. Okay, no, I just wanted to respond on that question about energy efficiency versus total energy use, because it's a question, and this I think was what Aaron was getting at. If you just go to what's it's me. I'm spooked. The issue is on refineries. Okay, is that better? Okay, the question that I think Aaron was referring to at a refinery, if you want to get your energy intensity index down, you increase the denominator. And so you're not actually reducing total energy consumption necessarily, but I think you were addressing a slightly different question. So you're saying your goal is to reduce total energy consumption rather than just improve energy intensity.
The Better Plans program, the way that it is set up is basically to reduce the energy intensity, not the overall energy consumption. However, from an energy intensive pilot perspective, we have not yet set any goals. That is what we are trying to figure out, whether the goal should be reducing the energy intensity, because obviously, like Alan mentioned, the more production, the energy is going to increase, right? It doesn't matter. So that is what we are trying to understand through the initiative, whether a realistic goal would be going through the energy intensity route or the overall energy consumption reduction route. But that is what we are going to try to figure out, working with you guys to see what would be more realistic. Yes.
All right, last question. We're on time.
I noticed that you had ISO 50001 up there, and I managed that for my unit. Within the ISO, you can define what's in your scope or not, or what is considered. So you can manipulate that energy intensity. Have you thought about that and how you evaluate when you send people out? How do they do that kind of thing within the ISO? Because my company, for example, will look at the total. But then in ISO, you can scope it out. So I was curious.
So first of all, to clarify, the one that we showed is not ISO 50001 certification. So that is a 50001 ready program. It's a self-attestation program that we partner with Lawrence Berkeley National Lab. So they are the ones who provide that 50001 ready navigator. So it's basically a segue to, it almost has most of the activities similar to what ISO 50001 certification has. So basically, if a plant is eventually trying to get ISO 50001 certification, 50,000 ready would be a good place to start, because it already has most of the activities that are involved through ISO 50001. To answer your second question, we do not get involved in the 50,001 ready process and what really goes in from an energy intensity or energy consumption perspective. But we can, put you up with a person who from Lawrence Berkeley National Lab who can, probably work with you and answer the question for you.
Okay.
Very quick. Yeah, the question from Zoomland was, how did you deal with proprietary information? Because obviously you've got these issues coming from companies like that.
So we deal with that all the time, even through our Better Plans program. So we can sign an NDA with the company, and so that's how we have done through the Better Plans program. So we can sign an NDA with the company through the initiative.
Well, thank you very much, Sunil and Zach. Giving them a quick round of applause. Thank you all very much. All right, and Zach actually included this in his one of his responses. So our next presentation is going to be around decarbonizing refineries and chemical plants with electrification and digitization. So Shabine and Yasmin are going to join us today from Schneider Electric. So Yasmin is the global business development leader for chemical segment Schneider Electric. She has over 20 years of experience in the energy and chemicals industry. Before joining Schneider, she had various technical and commercial positions in several leading EPCs and technology companies. She plays an active role in the chemicals market. She's an executive board member of AICHE in the South Texas section. She served as the board director for the Women's Energy Network, ECC, Future Leaders Program, and as the vice president of the Society of Women Engineers College chapter. So Yasmin, and then Shabine is the chief solutions architect, global process electrification leader within the energies, chemicals, and energies and chemical segment, Schneider. And he's been working more than 17 years. Has got numerous assignments across project businesses, engineering, R&D, and pre-sales functions. He's got a bachelor's degree in control systems engineering and a master's degree in systems architecture. So please give Shabine and Yasmin a quick round of applause as they come up to the thing.
Thank you.
Forward back.
Thank you so much. Yes, thank you for that kind introduction. I'm Yasmin Mokal. I do the first few minutes of this presentation, and I will pass it on to my colleague Shabine, and he's going to talk more in details about decarbonization pathways. I'm really excited to be here because decarbonization is really an interesting theme. We see it everywhere, especially in our industries. So really excited to be here to talk to you guys about what we're doing at Schneider when it comes to decarbonization. At Schneider, we are committed to sustainability. We want to be your sustainability partner by offering our digital solutions. We want to be your sustainability and efficiency partner. When it comes to ESG and sustainability, we really play from the both side of the equation. We have adapted ESG goals in our own ecosystem. We've been the #1 sustainable company in the past few years. So really excited to share some of our thoughts and what we're doing in ESG and sustainability with you guys. Today, more than ever, our chemical customers want sustainability. At Schneider, our goal is to bring resiliencies and efficiencies and agile operation through open software-centric industrial automation. And we think when it comes to sustainability, automation, software, and energy optimization are the key 3 pillars to bring our customers and our partner closer to their sustainability goals. So before we get into like the decarbonization pathways and what we're doing at Schneider, we want to kind of look at what's going on in the world. In the past few years, we've had the COVID-19 pandemic. We had Ukraine and Russia war, disrupted supply chain issues, and also we have an unpredictable economy. But one thing that remains constant is climate change. We've had devastating events with flooding, with droughts, hurricanes, freezing temperatures where places don't normally freeze. These events are really irreversible and devastating for people. So today, we see a lot of pressure from the stockholders, from the younger generations to decarbonize. But with the pressures high, we also understand there is a risk to access finance, and also there is risk to access talent. So how do we reach our net zero goals? We believe that you can reach your net zero goals by addressing low-hanging fruits. By that, I mean setting up short-term goals and long-term goals. And we need to also continue to invest into technologies. When it comes to short-term goals, we can address decarbonization by 35%, lowering CO2 emissions just by applying our existing technologies. So that is really good news. So we already have viable existing technologies that can reduce CO2 emissions by 35%. Some of the long-term goals, obviously, that needs a lot more investments and a lot more time. So we encourage our partners and our customers to continue investing into the long-term goals. And as I mentioned, we need to continue to innovate and bring the technologies up to speed for producing green hydrogen, green ammonia, blue hydrogen, blue ammonia, or CCUS. So let's kind of look at our numbers for CO2 emissions. These numbers are pretty high. These numbers came from 2021. 36.3 gigatons of CO2 emissions was a new record high in 2021 that came from the heavy industries. And we are on track. We are increasing our CO2 emissions by a 6% rate every year. When it comes to the heavy industries, 8.7 gigatons of CO2 emissions came from the power generation. So when you think about our industry, the heavy industries and chemical industries, these companies really rely heavily on power and energy. And it is one of the hardest industries to decarbonize because of their dependency on energy. And also because its demand is very high, so they can't really bring their productions down to address decarbonization. So we have to run the plants and still at the same time find ways to decarbonize. And this is kind of shocking because 78% of our industry in energy, the energy used in our industry is not electrified. So this is actually really good news because we have tremendous opportunity to electrify and use electrification as a way of decarbonization. Right now, about 80% of the energy in the industries is fuel-based. So really good news and opportunity to improve here. So when it comes to decarbonization, we have to think about it in two ways: digitalization and electricity. Electricity is the most efficient energy. So if you use electricity, you can bring your CO2 emissions down or have zero CO2 emissions. Digitalization is also very important. By using digital tools, you make invisible data visible, measurable and actionable. So with these two main pillars, we can really address the bulk of decarbonization. And as of today, we think in the chemical industries and heavy industries, 50% of the energy industries can be electrified. So with that, I'm going to pass it on to Shabin so he can talk a little bit more in detail about decarbonization pathways.
All right. So when it comes to decarbonization, I'm on the view that all options are on the table, right? I'm not saying electrification is the only way to decarbonize. All options are on the table. Yasmin mentioned the low-hanging fruits. So if I look at the decarbonization roadmap, I will put that into three buckets, maybe, right? The first one is the low-hanging fruits. So these are the things which we can easily do in our plants, in our facilities with existing technologies, and can be done cheaper most of the times. And if you look at some of the things like here, what I'm mentioning here, harmonic filtering, it's something which we don't pay attention most of the times, and also VFDs, right? There are many facilities still running with simple motor control system, not with a VFD. So these are the things that needs to be looked into. Also optimization and planning software. Correct implementation of that can bring the carbon footprint lower, right? So collectively, all these actions can bring down the carbon footprint by up to 35%. Okay, that's why we call it the low-hanging fruit. Now, to push further, to get to the next level, we need some paradigm change. When I say paradigm change, we need to relook the way we design, build, and operate our plants. For example, we are running with the fossil fuels for fired heaters and gas-driven compressors.
can we look into a different option like electrification of those things, right? So process electrification squarely falls into this category of paradigm change. Now, to push to the final stage of your decarbonization goal, we clearly need some breakthrough technologies in terms of carbon capture, or in terms of blue hydrogen, or in terms of, let's say, a new way of doing our chemical processes like photoelectric or electrochemical reactions, etc. Right? So that's the ultimate goal to get there. Now, all of the CO2 abatement options has a cost associated with, right? If you look at this graph, if you can see energy efficiency it's a no-brainer, right? It has an ROI even without a carbon tax in the US. So doing energy efficiency measures in your plant is going to be the first thing that you can achieve it. And if you look at these figures, electrification related topics, like including electric heaters and electrification of steam generation, has a higher cost today if you simply consider electrifying them. But the cost can be really lower if you consider by integrating flexibility into the process. That I will talk about that later in the process. Okay, and CCUS, of course, is an option, but it also has a major capital investment. It works in some cases, it doesn't work in some other cases, right? Especially if you have a hub concept, it has a better priority over electrification. But if you don't have a hub option, electrification might be a better option, right? Now, let's have a look at how we build a decarbonization roadmap or an electrification roadmap for the heavy industry. Right? When I say electrification, that's a journey. It's not a step change. That journey happens between when you decide on your GHG reduction ambition and the moment you get to that target, right? So things that happens in between. So it really starts with the assessment of the potential. When you think about an electrification project, you need to assess it has the potential to achieve that goal. So you start with a pilot project, okay? You need to have consulting and pre-studies there, and you need to have approximate quantification of savings with respect to that electrification. And once you have that plan, you prioritize the things to be electrified in your plan. Depending on your specific situation, specific processes, you will identify functions and unit to be electrified. It could be starting with the small heaters or small compressors and gradually move up to the large heaters and the large compressor units in the plant. Okay. In parallel, you also need to work on the power supply. This is very critical, right? I cannot jump into an electrification project without figuring out my power supply, where it is going to come from. So the green energy, the utility contract, and the hybrid generation model, all this needs to be parallelly thought out on that. And the final stage of this process, once you have already figured it out, you are in the decarbonization pathway with electrification. It's the time to think about leveraging demand side flexibilities. When I say demand side flexibility, it's both ways. The flexibility in terms of fuels, can I switch between my fossil fuel fired heater and the electrified heater, or can I have a hybrid arrangement? It's also about the storage mechanisms, right? The battery energy storage or thermal storage system. And finally, it's also about monetization. If I have flexibility in my process, can I monetize it by selling electricity back to the grid when the production is not feasible, right? So it's, like I said, it's a paradigm change in the way of thinking. We are used to operating our chemical plant 24/7, 367. Is that really going to be the way of operation in the next decade with electrification? It may not, I don't know. Now, I will consider any major strategic changes like electrification needs to have a comprehensive approach, right? So in that comprehensive approach, at the minimum, I will consider these four elements. Do I have a decarbonization strategy in place? Did I look at the alternative options? Carbon capture, all other things, hydrogen, green hydrogen, blue hydrogen. Did I look at all those options? Did somebody do a financial modeling of that to clearly say that electrification is the best path forward? So this is the first step to be done. And then you need to assess that if I'm going ahead with electrification, do I have the power purchase agreements in place? Can I secure the green electricity? All those things needs to be considered, right? The second element is, if you're going to be grid connected, do my grid have the capacity there? Do they have an energy management system that will support my flexibility goals, etc., right? Just to give you an example, a major project that's going on in the Permian Basin is to electrify their compressor stations. So one of the major player, just one player in Permian, once they're done with their electrification project, they're going to consume 30% of the utilities capacity there. So that's the scale of projects we are talking about. Now, most of the times we don't look into the power system, right? So today, 5% of your energy in a refinery is electric, right? Now, if tomorrow it's going to be 50% or 80% or even 100%. Do you have a strategy to evolve your power system there? Is your power system, the basics of your power system, is it stable enough to upgrade to that level? That's a big question to answer. And lastly, the process system. When I do electrification, my process is going to change. My energy balancing is going to change, right? So am I considering that as part of this transition? This is an important question. So you may need model-based predictive control, new process control strategy, energy rebalancing overall. All this needs to be considered. At least these 4 elements needs to be part of the strategic study you do. Okay. So if I try to simply classify process electrification into 2 simple buckets, we are talking about either electrification of motion, that's your compressors, motors, and pumps, or electrification of your heat, okay, process heat. And that's a larger part, which has been talked about. 72% of the energy used in refining and chemicals is going to be in that bucket. And that's the toughest part, right? Further, we can divide that into light processes or heavy processes. This is for the purpose of evaluating technical feasibilities. If it is a light process, as there is technology available, we can go through. But if it's a heavy process like crackers, electrifying, that is going to be a challenge. It's not impossible. We are engineers, we can solve anything, but the challenges are much higher there. And there was a talk, we are talking about electrification. Is it just about GHG reduction? We're talking about the gas price versus electricity price is going to be economic. We can do all kind of modeling. We have the tools, right? But electrification is not just about GHG. It is also about driving higher efficiency. If you say electric motors are inherently more efficient. Electric heating, the same way. Now, when we consider the lower maintenance cost that happens with electric drives, for example, gas turbines are 10 times MTBF. And if you look at MTTR, it's 10% lesser compared to gas turbines. Now, electrification also enables remote operations. It also enables you with better visibility and faster response time. That means theoretically, you need to have better process control there. You need to have better efficiency and yield coming out of electrified processes. And lastly, we talk about monetization of flexibility that will part of the equation. So when you consider the benefit of electrification, we need to consider all these, not just the energy cost, not just the capex. Yeah? Some of the challenges to look into when you start looking into electrification, very clearly, for any facility, major electrical infrastructure upgrades are required. Okay, so this needs to be a very serious concern that needs to be addressed as part of the strategy. And again, decide to go for electrification, make sure that as you have secured the green electrons required for that program, right? Again, high temperature electrical process, the controllability is a challenge depending on how you want to approach it. If you're talking about large heavy processes, you're talking about medium voltage heating. So the controllability of that process is a challenge again. And the scale of this electrification projects, when you're talking about a cracker electrification, we are talking about hundreds of megawatts of electric system in place. So those are complex projects to handle. I will summarize with this. So if you're trying to achieve your objectives of decarbonization with process electrification and decide to get on an electrification project, these 5 elements needs to be part of your ROI when you measure it, right? So of course, your goal is net zero operations. So you need to make sure that if that project is going to be sustainable with that, right? Once I electrify my processes, is it going to be carbon neutral? Do I have enough green electricity like I talked about? So net zero operations, the sustainability is going to be the key goal there. They reduce total cost of ownership. So I am embarking on a large project. What's going to mean by total cost of ownership? Can I optimize the capex? What is going to be the equipment efficiencies? Can I improve the process with better control? Things like that. Safety. This is a key parameter. We are all concerned about functional safety in our refineries and chemicals, But when I go to fully electrified operation, the electrical safety is going to be a major concern there, right? Then reliability of equipment, and finally the cybersecurity. So cybersecurity needs to be part of the equation as well. Just one I'd like to highlight. So I talked about the process control here. So this is your traditional process control system. You see, we control the burners in a furnace and you control the flow of fuel. But in an electrified system, what are you going to control? You're going to control the flow of electrons to a heating element, right? So this is a major shift in the way control strategies are applied. Now, mentioned there needs to be some key development that should happen to make this possible, right? So one of the technology I would like to spotlight here is the direct heating. This has the potential to replace the fired heating processes. So again, this could achieve, when I'm talking about direct heating, means applying electricity directly to the metallic tubes in a furnace. In this process, we talked about some safety challenges, but specifically the one we are working has a potential to work on safety voltages less than 50 volt, can achieve up to 1200 degrees Celsius of heat, okay? And this is suitable to retrofit the existing furnaces. That's a key thing, right? If you're coming out with a technology that is not feasible to retrofit existing facilities, that's not very useful. So this technology has the potential to retrofit existing furnaces, okay? All right. We're on time. Yeah. So I'll stop there for some questions.
Perfect. Good job.
Okay, so Q&A. We got a hand up.
Do we dare try this? Yeah, that's go for it. It's gonna work? Good. Okay. Your last one's the most important, right? You're talking about, I think, a steam methane reformer, not a small modular nuclear reactor.
No, we're talking
Okay.
about Smith.
What is the most important thing when you operate a steam methane reformer as an operator? Right?
Yep.
You go and shoot the tubes to see how hot they are, right? Because they fail, they creep. It's very important.
Yep.
Now you're going to use some big induction or it's an induction heater on the tube itself, correct?
Okay,
and
so
what happens when you lose the process flow, which is taking away that heat? Do you melt the tube at the end of the day? I know there's problems you're trying to encounter, but they're big problems.
Yes. Very clearly, yes. So the technology which I'm talking about is radiative heating. Using a heating element on the periphery is an option. But when you apply electricity directly to the tube, that's a whole lot of different challenge. So this kind of solution, we are not a process licensor. We are not a process technology company, right? And we know that the industry cannot solve this problem by itself. Schneider Electric, we won't be able to solve this problem, and a process technology company, they won't be able to solve this problem. So we are working on a collaborative ecosystem, working with process licensors and furnace manufacturers who work on these processes, working with them to pilot these projects.
Can I add a little extra?
Yeah.
In terms of heat flux is critical.
Yes.
And I don't know quite how you can do that electrically. Whereas a fired tube, you've got the radiant heat of the flame itself at 2,400 degrees Fahrenheit.
Yeah.
Radiating on the tube.
Yeah, I think on an average, you're talking about 50,000 per square meter heat flux. So right now, we can achieve the similar levels of heat flux with this technology, but it's clearly dependent on the diameter of the tube. The smaller diameter, the better. The higher the diameter, the biggest challenge is then the voltage level goes up to achieve the same heat flux. So my goal is to keep the voltage less than 50 volt. That's a safety voltage level. So you can go and inspect your tubes. You can change your catalyst without PPEs, etc. But yes, the voltage level will vary depending on the diameter of the tube once you change it. Yeah.
Oh, we'll pick Alan, any online?
So it's, the last time I've read anything about this, the conversion process from natural gas to electricity is very inefficient. So have there been any improvements recently to significantly improve that conversion efficiency?
Yeah, so when we consider the whole heat integration in a chemical process, right, like ethylene cracker or SMR, it's a full heat integration. It is up to 90% efficient, today's technology, with all the heat recovery systems, etc. If you simply put an electric heater in place with induction, with radiative heating, that's going to be 30 to 35% efficient. So in that way, you are absolutely right. It's inefficient, right? Replacing a fully efficient system, like 80% efficient system with a 35% efficient system, it's not a good thing. That's exactly what we are trying to address with this. And the initial test and the pilots we are doing on this showing it's around 85% efficient in this.
The electricity producers now for the grid.
Okay.
That's specifically what I was addressing, the
Inefficient. That's inefficient. If you're applying the grid electricity with all the transmission losses, if you're talking about it, yes, today it's inefficient. If you have local green generation, that's the best way to go for. Okay. But now again, if the target is GHG reduction, then like I said, you model all the alternative options you have available, and then you decide the best option to go for. Yeah.
I just one, most of us here, I deal with plants and all that and design. So let's say I need 100 million BTUs an hour of heat input to a process. So current technology on fired heaters is, I probably got about 8, maybe 10, at best 8% of that goes. I don't get it. It goes out to that's about as good as I can do. I got the cost, energy to get the fuel to the heater, the same thing. So I haven't done the calculations. I'm just on an electric basis to get the same amount. Basically, I need 100 million BTUs of heat input. I haven't done the calculations, but I think that's the thing you need to look at. What's the well-to-wheel cost or energy cost or energy consumption to get that same amount of heat input, into a process, because that's what we all deal with. We need to get heat into processes. That's what we're all about, heating stuff, right?
Sorry, was there a question?
Full analysis, well to wheel.
It's a comment.
Okay.
Yeah.
Sure. You're talking about burning fuel and
Yeah. Yes.
Yeah, so I'll kind of give you an example. We evaluated electric heat versus natural gas heat in a process at one of our facilities, and the capital on the electric was much higher. But as we realized that once we put that thing in, it was going to be emitting for 30 years, and that's beyond the life that we want to decarbonize that process, and we'd have to basically pay the piper down the road. I'm talking about that ultimately, well, the price in the carbon is zero. In Europe, it's $100 a ton, 100 euros a ton. Yeah, it's not there yet. But, and DOE talked about the carrot, right? That there's a big carrot out there for. Yeah, but the transition to electrification, if you can do it more efficiently and save money, like it's not just making electrons at the grid, it's also being able to deploy them efficiently. And that's where Schneider's really good. Sure. Yeah, it's an important part. Sorry, question here?
Yeah,
We'll get you next.
so just want to address the elephant in the room because we're going all the way to the energy side, the engineering side. So industrial decarbonization, electrification. But we all know, or should be aware, that the grid is a multi-trillion-dollar effort. and we have to fix the grid and make it be a smart grid of tomorrow. Because you're trying to now hook up industry to a grid that can't support what it's trying to do today. And I'm not just talking from a weather system perspective. I'm talking from ISOs, the RTOs, the 3 different grids. So what are you doing? You're talking about using electrification, industrial decarbonization, and you have to worry about a grid that's antiquated.
Yes, absolutely. So I'm part of energies and chemical segment also on the end user side, but there's a big group of people who work with the utilities and working on the grid upgrade programs. It's clearly, if you're going to be connected to the grid, there needs to be enough green power available on the grid to make this work. And at the same time, the grid infrastructure, I talked about it, there needs to be major upgrade that should happen behind meter as well as in front of the meter, okay? So same case for the facilities as well. Your current electrical infrastructure is nowhere near ready for this. I just, yeah. So this should give you the picture, right? Your current system is around 20 to 50 megawatt of electrical system. You're talking about an electrified chemical refining plant. You are talking about 300 megawatt to 1 gigawatt electric system. So you can see that's a big transition. That's also the reason I'm not thinking that's a step change. This has to be a gradual change. That's why we emphasize digital. How do you plan that transition over a 10-year period or 15-year period? And your electrical infrastructure, you're putting it today, can be in use 15 years after and support that transition. Same for grid. Same for grid.
All right, got about a minute left, so we'll do these last 2 questions. So go ahead. Okay, so for online, the question was, what would be the main fuel to generate all the electricity?
Okay, so there are pathways to get there, right? I mean, we're talking about a gigawatt scale electric system. You have multiple pathways to get there. So either through power procurement or power purchase agreement that you can collect all the green electricity available in the Texas grid and bring it to your use, or you can ask the technology, a combination of virtual power plant, microgrids, energy storage, thermal storage, all this combined together, you can bring it a grid system of your own. So there are multiple ways to get there. Preferably, it has to come from a green source. Wind, solar is not an option, but wind is of course a good option. But we are also considering as part of industrial microgrid. I don't want to call it as a microgrid anymore. When you're talking about a gigawatt scale system, that's not a microgrid. It's a mega grid. And the technologies like SMR, in this case, not steam methane reforming, and talking about small modular reactor is also an option to be integrated as part of the grid system. Okay, so this should give you an idea of how a future grid system, if you're going to be a standalone grid system, how the generation is going to come from. So mixed renewable plus SMR plus thermal storage all combined.
All right, one more question.
Well, I was going to suggest that the only way we're going to do this is through nuclear small modular reactors. So you stole my thunder. There's no other way, particularly in the ERCOT grid. The ERCOT grid is very, very unreliable. I have a colleague who tells me that in 2 more years, we're going to have major problems. So nuclear SMR, that's it. No other way.
Absolutely. There has to be breakthroughs there. But again, when you talk about this electrification at this scale, it's not going to be a step change. I want to repeat that. It's going to be a gradual transition. Okay. So you're going from a 50 megawatt system gradually to a 300 megawatt system. So the same infrastructure upgrade should happen behind the meter and in front of the meter. Okay.
Perfect. Thank you, Shabin, and Yasmin, give him a quick hand. Thank you. All right, Alan, are we stopping the recording?